Hey, 7th grade, I'm back with your second lesson for the week. We're going to be working from Chapter 9, Lesson 3. The title of the lesson is Probability of Compound Events. And you guys are going to need your math book. We're going to be starting on page 736. You're going to need a pencil, and you may want some paper just because there's going to be a lot of list making in today's lesson, and you may find that you run short on space in your book. So that's kind of up to you. Your book, open to page 736, a pencil, and possibly some paper, okay? I'm going to do a quick introduction of what the concept is going to be, and then we're going to get right to the book. I'm going to try to keep this lesson a little shorter than yesterday's. Okay, so we're still dealing with probability, the likelihood of something happening based off of the possible outcomes, okay? And today we're going to be focusing on something called sample space. You're going to hear this term a lot. You're going to see it in the directions. You're going to hear me using it. Sample space simply refers to all of the possible outcomes in an event. Okay, and I'm going to show you what I mean by that. I've used a very simple example here to show you. I've got two baseball caps. I've got a red one, I got a blue one, and then I got, from just my closet in there, 3 different pairs of earrings. I've got blue, I've got white, and I've got gold. Okay, so 2 caps, a red and a blue cap, 3 pairs of earrings, blue, white, and gold. Okay, and what I want to do is I want to create a sample space that shows all of the different possibilities or the possible outcomes of the combinations of hat and earring pair that I could combine. So just to kind of give you some tips and hints on this. The first thing I did was list my 2 different cap colors, which were red and blue. And then I listed my earring colors, blue, white, and gold. Now, here is a little trick. It's called the fundamental counting principle, and we're going to actually get into it in a couple of lessons that can help you make sure you're doing your sample space correctly. If I want to list all the different possible outcomes of combinations I can make between caps and earrings, I can use multiplication to figure out how many different outcomes I could possibly have, okay? So there are 2 colors of caps, and there are 3 colors of earrings, and I can multiply those 2 different outcomes together. And I know that when I do my sample space, I should have 6 different combinations or possible outcomes, okay? Now, a couple different strategies that we can use to list our sample space, and really, to me, it just sometimes one is better than the other, or sometimes you may just have a personal preference like we often do in math. One is a tree diagram. A tree diagram, and I'm going to show you how to do it here, is where we take, typically like on this one, I'll take the caps, red and blue, okay? And then I'm just going to make little, since there's 3 different options of earrings, I'm going to make like 3 little branches coming out. Some people do their tree diagrams going out horizontally rather than vertically. That's okay too. So what I could do here is I could say, okay, if I have a red cap, I could do a red cap with blue earrings, a red cap with white earrings, or a red cap with gold earrings. So that's 3 different possible outcomes. Or I could do a blue cap with blue earrings, a blue cap with white earrings, or a blue cap with gold earrings. So there's 6 different possibilities, okay? Now, another way we can do this is we can make a list, okay? A list is quite simple. I'm just going to use abbreviations for sake of time. So I could do a red cap with blue earrings, a red cap with white earrings, or a red cap with gold earrings. I can do a blue cap with blue earrings, a blue cap with white earrings, or a blue cap with gold earrings. Now let's talk probability for a second. What if I wanted to know the probability of me selecting or combining the same colored cap and earrings? So obviously the only option here would be a blue cap, blue earrings, okay? So I've now got my sample space. I've got my outcomes, okay? There are a total of 6 different outcomes. And one of those is the same color cap and earrings, okay? So I could say, if I wanted to, let me see if I can flip over on the back and use this and it work. I could say that there's a 1 in 6 chance of me getting the same color cap and earrings. And I'm gonna grab my calculator right here and I'm gonna get a percentage on that now. It comes up to this. And if we round that to the nearest percent, we would say that there is about a 17% chance that we could get the same colored cap and earrings. But we needed to know our sample space and our possible outcomes for that happening, okay? These are called compound events simply because you have more than one event happening in the trial. We're picking a cap, and then we're also picking a pair of earrings. So you have more than one event happening. So we call these compound events. So I'm going to stop the video, get my book ready, and we're going to practice creating sample spaces from different compound events together. Again, you're going to need your math book. Open to page 736. You'll need a pencil. And if you think you don't have enough room in your book, you may want to grab some notebook paper. Okay? Okay. So we are back and we're on page 736 from our math book, and we're going to start with the guided practice now that we've introduced the concept. And for numbers 1 and 2 here, it simply wants us to find the sample space. Now, in other words, that just means list all the different possible outcomes for each situation. We can do that using a tree diagram or a list. I'm going to probably do a list for number 1 and a tree diagram for number 2, just so that you can see them both in action, okay? So number 1 says a coin is tossed twice. Now what I like to do before I do my sample space is I like to sort of get an idea of how many possible outcomes I should have. So I know that a coin has 2 sides or 2 possible outcomes. So I'm gonna toss it once, I can get 2 possible outcomes. If I toss it the second time, that's 2 more possible outcomes. So if I multiply those 2 outcomes for each flip together, that tells me I should have 4 different possible combinations of outcomes in my sample space. So that just kind of allows me to check myself and know that I'm doing it correctly. All right, so I know that we have a coin with heads and tails, so I'm gonna start by just making a list. And I'm just gonna assume that on the first coin, I get heads. So I flip heads on the first coin, and let's say that I flip heads on the second coin. Then I flip heads again on the first coin, but then I flip tails the second time. Now let's flip it around and say, okay, well, what if we flip tails the first time? Well, I could flip tails the first time and then heads the second time, or I could flip tails and tails again. Okay, so there is my sample space. That's all there is to it, all of my possible outcomes. Now you could take it one step further. If someone wanted to know the probability of you flipping the same side of the coin, okay, here's how you would do it. Even though it's not asking us to do this, I just want to make sure you understand how you could. We know that we have 4 possible outcomes there. 2 of them have the same side of the coin being flipped. So 2/4, which is the same as 1/2 of the time, which is the same as 50%. We could say that the likelihood of you tossing a coin twice and getting the same side of the coin would be about a 50% chance. Now, it's not asking us to do this right now. It's simply asking us to get the sample space, but I'm just wanting to connect this to what we've learned so far. All right, look at number 2. I'm going to use a tree diagram on this one. It says a pair, you have a choice of a pair of brown or black sandals. So that's 2 possible outcomes on sandals. And you can get them in sizes 7, 8, or 9. So that's 3 outcomes for sizes. So we know that if we multiply those together, that means we should have 6 combinations when we're finished. Now, this time I'm going to do my tree diagram horizontally, just so that you can see it's the same thing. I just want you to see all the different possible ways this may be presented to you. So we could start with our 2 different colors of sandals. Brown sandals and black sandals. Okay? I know that I could get brown sandals in a size 7 in a size 8, or in a size 9. So there's 3 different combinations if they're brown. I could get black sandals in a 7, 8, or 9, okay? So you have 6 different outcomes there. And again, if you were asked a probability question, kind of like, what is the probability of you getting an odd-sized brown sandal? I'm just making this up, an odd-sized brown sandal. Well, a brown 7 and a brown 9 are odd-sized brown sandals. So I could say that if this were the case, there would be a 2 in 6, or that simplifies to 1 in 3 chance of that happening, which would be about a 33% chance of you getting an odd-sized brown sandal. Again, it's not requiring us to do this, but I'm wanting to make connections to what we've already learned with you guys. All right, moving on to number 3. This one says, Gerardo spins a spinner with 4 equal sections labeled A, B, C, and D twice. He spins it twice. If letter A is spun at least once, Gerardo wins. Otherwise, Odell wins. Use a list to find the sample space and then find the probability that Odell wins. Now, we know that each spin, there's 4 possible outcomes. And because they're spinning it twice, that's 4 outcomes possible on the first spin, 4 outcomes possible on the second spin. So we know our sample space is going to have 16 different combinations in it. And this is kind of just a tedious thing, but all I need to do is start. So I'm going to start with spinning an A on the first spin. So I could spin an A, and then I could spin an A again on the second spin. I could do A and then B, A and then C, A and then D. That's all the ways that I could spin an A first. Now let me go with B. I'd always like to have a method to my madness, some order here, so I'm just going to go A, B, C, and D. So I could do a B with an A B with a B with a C, a B with a D. Let's say I spin C first. C and then A, C and then B, C and then D, C, sorry, and then C and then D. Or last but not least, I could spin a D first. So D with A, D with B, D with C, D with D. If you count those up, you got 16 possible outcomes, so we know we're on the right track. Now, this question's wanting us to connect the concept of probability to it. It says, if letter A is spun at least once, Gerardo wins. Otherwise, Odell wins, okay? And we're wanting to know what is the probability that Odell will win. So Odell is going to win as long as there is not an A included in the sample space. So it can't be any of the first 4. It can't be this one. I'm just going to highlight the ones that Odell could win with. Anything without an A, Odell can win with. If it has an A in it, it says Gerardo would win. Okay? So there are 16 possible outcomes here. 1, 2, 3, 4, 5, 6, 7, 8, 9 of those outcomes would allow Odell to win. We can take and also convert that to a percent because probability is often written in percentages. So we would say there is about a 56% chance that Odell could win. A 9 in 16 chance or 56% chance that Odell could win, okay? All right, moving on to your independent practice. On the next page, 737. Same thing for each situation, find the sample space. Now I'm gonna stick to the directions on this one. I think I've done enough for you guys to kind of have an idea of how this would connect to probability. And we'll see a couple of those, I think, before we stop. So on the first one, it says, we want to know the probability of tossing a coin and spinning the spinner at the right. Well, first of all, let's get an idea of how many different ways these combinations could take place so that we can know we're on the right track. I know that there are 2 different outcomes on a coin, and I know that that spinner has 5 different outcomes, so I should have 10 different combinations in my sample space when I'm done, okay? On this one, I'm going to use a tree diagram on this one. I'm going to kind of mix up my strategies, okay? So I know I can toss heads, and I know I can toss tails, okay? Now I could do heads with a 1, heads with a 2, heads with a 3, heads with a 4, and heads with a 5 on that spinner. I could do tails with a 1, tails with a 2, 3, 4, and 5, okay? So there are 10 different possible outcomes in this sample space. Number 2, we want to show the sample space or all the possible combinations of picking a number 1 to 5 and choosing the color red, white, or blue, okay? So I know I have 5 different outcomes in my numbers, 3 different outcomes in my colors. So when I'm finished, I should have 15 different outcomes in my sample space. I'll do a list for this one. I'm going to start with my numbers. I could do a 1 with a red, a 1 with a white, a 1 with a blue. Now you see me making a list. I could do a 2 with a red, 2 with a white, 2 with a blue, 3 red, 3 white, 3 blue, 4 red, 4 white, 4 blue, 5 red, 5 white, 5 blue. And then if you count them up, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we know that should include all of the possible outcomes. Okay? Number 3, we're wanting to write the sample space or show the sample space for choosing a purple, green, black, or silver bike that has a 10, 18, 21, or 24 speed on it, okay? So again, we've got 1, 2, 3, 4 outcomes in our colors. We've got 4 outcomes in our speed. So we should have 16 different possible outcomes in our sample space. I'll do a tree diagram on this one, again, just mixing it up for you guys so you recognize the presentation of list and tree diagrams. Let me start with purple. I could do purple in a 10, 18, 21, or 24 speed. I could do green in a 10, 18, 21, or 24 speed. I could do black in 10, 18, 21, or 24 speed. And then I could do silver in a 10, 18, 21, or 24 speed. And then you can see that you have 4, 8, 12, 16 different outcomes there. Number 4, choosing a letter from the word space and choosing a consonant from the word math. So I have 5 different letters in space, so 5 outcomes there. But now on this next part, it says a consonant. Now I remember last year, my 7th graders couldn't remember what vowels versus consonants were. Remember, your vowels are A, E, I, O, or U, and then your consonants are anything other than your vowels. So in the word math, there are 3 consonants, M, T, and H. So there's 3 outcomes for getting a consonant in the letter math or in the word math. So we have 15 possible outcomes here. I'll do a list for this one, okay? So I could do, I'm gonna underline the M, the T, and the H. So I could do an S with an M, an S with a T, S with an H. That takes care of all my S's. I could do P with M, P with T, P with H. Going on to A with M, A with T, A with H, C with M, C with T, C with H, and then E with M, E with T, and E with H. So there you have your 15 possible outcomes there. Number 5. Now this one's going to have us connect this to what we've learned about probability so far. It says for each game, find the sample space and then find the indicated probability. It says that Elena tosses 2 number cubes. She wins if she rolls double 6s. Find the probability. Remember, P outside of parentheses stands for probability. Find the probability that Elena wins. So she wins if she gets 2 6s. Now it tells us in our directions we need to find our sample space. I know that there are 6 outcomes on a number cube, and if she does 2 number cubes, that means there are 36 possible outcomes, okay? So I'm just gonna make a list here. I think that'll be the easiest way to do it. I'm gonna start with if she rolled a 1 on the first cube and then go with all my different outcomes on the second cube. So she could do a 1 and then another 1, a 1 and a 2, a 1 and a 3, 1 4, 1 5, 1 6. Then she could do, let's say she rolls a 2 the first time on the first cube. She could do a 2 and then a 1, a 2 and a 2, 2 and a 3, 2 4, 2 5, 2 6. 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. This is just tedious. Do my 5s. And then last but not least, if she rolls a 6 first, she could do a 6 and then a 1, 6 and then a 2, 6 and a 4, 6 and a 5, 6 and a 6. Now, it says so that's our sample space. Those are our 36 possible outcomes. And it says she wins if she rolls double 6s, okay? So on this specific problem, there are 36 outcomes. Only one of them are double 6s. So there's a 1 in 36 chance. If we want to get that as a percentage, it's not very good, okay? That's going to be at most about a 3% chance if you shift that decimal point. So a 1 in 36 chance, or about a 3% chance that she could win here, okay? Number 6 says Ming rolls a number cube, tosses a coin, and chooses a card from 2 cards marked A and B. So this one has 3 different events happening. That's what a compound event is, anything that has more than one event happening. So we're gonna roll a number cube, toss a coin, and then choose a card. It says if she has an even number and heads appearing, she wins, no matter what card is chosen. Otherwise, LaShonda wins. Find the probability that Ming wins. Let's first of all figure out, using multiplication, how many different outcomes we could possibly have. So if she rolls a number cube, there's 6 outcomes there. She tosses a coin, that's 2 outcomes. And then she has a card that has an A and a card that has a B, so that's 2 outcomes there. Well, 6 times 2 is 12, times 2 more is 24. So that means there are going to be 24 possible outcomes in this sample space. That just kind of gives me an idea of what to work with, okay? So I'm going to go ahead and I'm going to get started. I'm going to start with if she rolls a 1, and I'm going to then go with heads and go from there. So she could roll a 1. She could flip heads and get card A. She could roll a 1, flip heads, and get a B. She could roll a 1, flip tails, and get an A. Or roll a 1, flip tails, and get a B. She could roll a 2, flip heads, an A. 2 heads, B. 2 tails, A. 2 tails, B. And I'm going to keep on doing this all the way through 6. I'm not going to talk it through because I know that probably gets annoying. So I'm going to sit here and write them out really quick. Last but not least, I'll get 6 here. 6 heads in A, 6 heads in B, 6 tails in A, 6 tails in B. Now, so there's our sample space, and we should have 4, 8, 12, 16, 20, 24 different outcomes there, so we know we're good on that. Now, we want to know the probability of me winning, and it says that she wins if an even number and heads appear. So I'm going to go highlight those. So my only even numbers are 2, 4, and 6. So my winning combinations can only come from those rows. So it has to be an even number and heads. So these two, and these two. Okay? So we had a total of 24 outcomes. 2, 4, 6 of those have an even number with heads. And if we reduce that to its simplest form, it's 1 in 4. So the probability of her winning is a 1 in 4 chance, or we know that's the same as 25%. Okay? Now, I'm going to stop teaching there for today, but I am going to tell you, just like I did in the last lesson, on page 739, it's the extra practice. If you are just wanting to do some extra on your own to see if you understand, I will work this and post a picture on Remind so that you can self-check yourself. You do not have to. This part is optional. You can send me a picture of the bookwork we did together from the lesson video, and that is enough to show your learning. But definitely, if you guys are wanting to push yourself, try page 739, and I will post a picture of the answer keys for you guys to check yourself. All right, these are your 2 assignments, lesson 9, chapter 9, lesson 2, and chapter 9, lesson 3 for the week. I'd like to see some work back from you guys through a picture on Remind by Friday. Thank you.